dialogue I am using. But this time for session 10 also, Sir Dr. Narasimha sir, he is from Andhra University, working in computer engineering department. Sir is also very expertized professor in teaching machine learning, deep learning, and most important thing is he has done a wonderful one project around 4 years. Around 4 years about the fire detection in the forest. So that project again funded by the Chunoti, that is by the Software Technology Park of India. So sir has got funding also. So he has done a wonderful job and still is continuing. So sir is again a product of India. He also working with them. So with this you can understand that how beautiful and talented persons are there in the India. Okay. So thank you so much for accepting our invitation, sir. Now the sir is going to start the session about the neural networks. So grab the opportunity, utilize his knowledge, ask questions. Okay. Don't only think for time that whether I'm getting hungry, go for lunch, don't think that. That is all will be there anyhow. Okay. Okay. Anyway, by the way, are you all happy with the food? Is it good? Cookies? Good. Okay. Right. Thank you.
We are in the era of hybrid intelligence. Artificial intelligence that is connected to linked intelligence. But as per hybrid intelligence, we can use many technologies. Okay, like artificial intelligence, machine learning, deep learning, IoT, blockchain, cloud computing, remote sensing, and GIS. It's a huge technology. Which one? Hybrid intelligence is huge technology. Okay. Whereas, as per the artificial intelligence, we can go different classifications. Okay. Where the first one is machine learning. Before the machine learning, we should know what is the neural network. Okay. Neuron means the cell body. The cell is a small cell. Okay. In our brain, many neurons are there. Billions of trillions of neurons are there in our brain. Okay. So every neuron that will pass you something from the environment. Every neuron, every cell body, every dendrite, every axon that will pass you something from the environment. Okay, let's consider where it is sunny or it is raining. How can we pass you through your eyes? Yes, right? So that means it's a sensor. The sensor will pass you something. Same thing, the neurons will pass you something from that environment. Okay, right? So after grasping of some information that will collect in a single database. Okay, what I pass you, then what we do? We can store it. Yes or no? We can store as rows and columns, tuples as well as attributes. Then we can do some analysis. Okay, we can do some analysis. How can we do analysis here? exploration. What we do here? So that's why we have to introduce different technologies. Where the first one is neural networks. Okay, neural network means, okay, before going to the neural network, what's the network? We are all network. Yes or no? We are all network here, right? So network means what is? It's a combination of different systems. That's a network. Okay, so in our general language, local area network is there, wide area network is there, metropolitan area network is there, geographic area network is there. Okay, these are all different networks. What do you mean by LAN here? Local area network, right? So here many servers are there, many systems are there, many clients are there. Okay, how can we combine all these systems to the LAN? For the connection to the LAN, local area network. Okay, so is it internet or intranet? We can use intranet as well as internet. I'm telling the basics of how can we do neural network. In the neural network, net is there, net. Okay, but here in our real time, we can use different types of network. But the first network is LAN, local area network. Okay, so in this local area network, so that is belongs to any organization or the industry or the lab or the classroom or something. Okay, right? So the network is local area network, right? So here we can use different Ethernets, okay, intranets, okay, so on and so on, right? So whereas, as for the local area network, we can use different protocols. Next one, we will switch from local area network to some other. We are combining, so this lab into other lab. Then what we do here, we can wide it, wide. We can extend it, we can explore it. How can we explore here? We can combine, okay, this network, that means we can combine, so this lab with some other lab. So that's why what we need here, wide area network. So wide, okay. So far what we discussed, only LAN. Then wide area network. Then I would like to switch from wide area network to the some metropolitan, some city. Okay, this lab, this college, or this industry must be connected to the GDMC. It's a metropolitan. Okay, it's a metropolitan city. How can we connect to the which one? MAN. Got it? How can we call? MAN. So metropolitan area network. Then we're switching from GDMC to what? Satellite. No, the earth. Yes? Then how can we do here? We have to use geographic area network. That will cover entire world. So that is the new one. Okay, based upon the plan, we can arrange our satellites. Okay, so in that satellites, we can use different technology. The first technology is remote sensing. And the second one is GAS. Okay. Whereas the LAN, WAN, GAN, or MAN, or whatever it is, what we follow some protocols. So that's why what we are using here, TCP, IP protocols, as well as UDP protocols. Okay. So that means something that belongs to which one? Wide communication. Something that belongs to which one?
Hello, Moto.
Okay, net means what is? Group of systems moving together. It's a net. Same thing, group of neurons moving together. These are all different neurons. You know, brain, different neurons are there. That will move together. Okay, so that's called the brain. The brain will think. Okay, the brain will think as well as the brain will work. The brain will send some signal. Based upon the signal, okay, I can rise up. Okay, I can move here. From where? From the signal. From the neural network. Is that wrong? Right? Same thing, we have to build such type of neural networking machine. Just like our brain. Just like our brain. Okay, in our brain, many neurons are there. Same thing. So that in that machine, so it has some programming. Okay, it has different chips. Okay, maybe nanochips, microchips, macrochips, circuits, gates, binary codes, digital formats, so on and so on. Okay, let's consider the system is there. So background, which one is there? Genome mass format is there. It's the digital format. It's the binary format is there. Okay, 0 means what is off, false, low. 1 means what is true, on. Yes or no? High. Same thing here in our neural network. 0 means what is switch off. Switch off. 1 means what is activation. Okay. 1 means what is activation. 0 means what is switch off. Okay. Same thing here in our neural network. We can use different memory cards. Okay. How can we build such type of memory cards here? The circuits. What's a circuit here? It's the combination of different gates. AND gate, OR gate, NAND gate, NOR gate, XOR gate. So these are the different gates. Okay. So each gate, I would like to open this gate. Okay, see, I would like to open. Okay, I would like to go to shopping mall. Okay, right? So automatically, based on the object, okay, here object detection is there. 1 meter range is there. Let's consider here door is there. Okay, here object is there. Okay, right? In between was the range here 1 meter. When the object will find out, automatically the door will open. Yes or no? The door will open. That means what happened here? Is it 1 or 0? The door will open. That means 1 or 0? 1. Okay. So it indicates what is 0 means the false. Right? So same thing here, in this brain, different methods are there. Different loading techniques are there. Same thing, in machine brain, we can use different techniques, like algorithms. What we use? Different algorithms. Right? So in this human technology, we can combine machine technology. So where we are? Hybrid intelligence, not in artificial intelligence, hybrid intelligence. So as for the hybrid intelligence, what we follow? Huge technologies. What are those? AI. Next one. Machine learning. Next one. Deep learning. Next one. Transfer learning. Next one. IoT. Next one. Industrial IoT. So on, so on. So as for the IoT and industrial IoT, what you learn? You have to learn all the sensors. How can you open the door? Some sensor is there. It has some law. It has some condition. Okay. If the condition is true, automatically the door will open. If the condition is false, what happened? That was in the closed room. Okay. Right? Same thing here. In our neural network, we can use different inputs. Okay. I would like to move from left to right. So that means what is? We are passing the signal. From where? From the brain. Same thing. The signal is called as what is? It's the input. So now, here also, we can give many inputs to our brain, our network. The brain, let's consider these are the 4 inputs or the 5 inputs. Okay, right? So here, the first one is x1, x2, x3, x4, x5. Got it? So we are inputting which one? Our brain. Then, based upon that input, the brain will process. The system will process. Okay. Then, after processing, what happened? That will give some output. So, in this case, so that is which type of output we have to gather. You have to calculate the accuracy of the output. Okay. How can we find out the accuracy of output here? See, suppose I would like to use 5 inputs. Here I will give some algorithm. Based upon that algorithm, I have the output range of 98%. The accuracy is the 98%. Okay, I may use different algorithms. Okay, first algorithm is SVM. Okay, random file. Did you see that one? You have the other names? Yes or no? Or that will give output. Okay, maybe 98%. Some other value, SVM, that will give 96. Okay, K nearest neighbor, that will give 90%. K without, that will give 80%. What happened here? It's not same. It's not wrong. Inputs are same, but output is different. What is 80%? What is 90%? What is 99%? What is 100%? Which one is varying? Which one is varying? The output is varying. Yes? Yes or no? Here, I am telling the class. Okay, I am telling the seminar, guest lecture form. How many members are grasping? Few. How many members are responding? Few members. What will remain? Okay, that indicates what is, how can we grasp? How can we use the algorithm? How can we use different epochs? Doesn't matter. Okay, right? So that's why neural network means what is the combination of different neurons. We can process all the neurons based upon the environment. Then we can build a different output. Okay, right? Listen carefully. So a simple example is that you can easily understand. Okay, what's a neural network? Okay, see, all of you concentrate here. I would like to prepare 100% tasty cup of coffee. Okay, 100% tasty cup of coffee. I would like to prepare. Okay, not 99.99%. Okay, not 80%. Okay, not 60%. My goal, my threshold, my peak value is what is 100%. Okay, 100%. How can we do here? Right? So what are the ingredients for preparation of the coffee? I'm asking, how can we prepare the coffee? Okay, yeah, what do you want? Very good. The first one is milk. Okay, coffee powder, sugar, water. Okay, and yes sir? Right. Okay, see, yeah, same. How many inputs are there? 4 inputs. Okay, here I am using one other something, another. Right? So coffee powder, milk, sugar, water. Okay, where the accuracy is 90%. When you are giving 4 inputs to the algorithm for your preparation of the coffee, but it has the accuracy of what? 90% only. About 10%. No, I'm not satisfied. What do you want here? 100% tasty cup of coffee. What's the gap here? 10% gap is there. Okay, I don't want. Acceptable. I rejected it. Okay. Yes. So what we do? What we do here? But what I need? 100%. Okay. Then what we do here? See. Same sugar. Same coffee powder. Okay. Same milk. We can reduce the level of what? Water. We can reduce it. Otherwise, we can ignore it. Otherwise, we can delete it. I don't want to take water. Okay. So what I will take here? Sugar, then milk, coffee powder. Oh, then the accuracy is 98%. Is there? What's the gap here? 2%. What we do? What we do here? Maybe you are using for thickness, you are using more coffee powder. Reduce it, please. All of you, please reduce it. Yeah. Okay, that means what happened here? Maybe your input is wrong. You have to reduce your coffee powder. Yes, you have to reduce your sugar. Okay, right? Then you will take thickness of the milk. Finally, you will get 100%. Yes? What's our threshold? 100% tasty cup of coffee. Okay, what is this one? Oh, this is also 100%. This is equivalent to this one. This is my 100% is my aim. Okay, what I processed? The first one 90, second one 98, and the third one 100%. Therefore, this one is equivalent to which one? My threshold value. Okay. Finally, in this process, which one is there? Algorithm is there. Which one is there? Algorithm is there. Okay. So that's why we're using different algorithms. Different algorithm. Suppose one algorithm is not good, then what we do? We can deploy some others. That algorithm is not good. Okay, it has some accuracy, but there is no optimality. Then what we do is we have to replace it, simply replace it. Okay, then we can use the third one, fourth one, and so on. So this is our neural network. Got it? We can use different inputs. Then we can use one processing unit, right? So these are all inputs. Then this is the processing unit. This is the output here. Okay, right? Something. What we get here? Accuracy. Here the accuracy is low. Then what we do? We have to modify. You have to modify. Alright? So that one is called as what is? The first one is called as 90% accuracy is called as feed forward neural network. What's the network? Feed forward neural network. When we found some gap is there, then we can go back and we can modify your inputs. That algorithm is called as back propagation algorithm. Okay? What the first one? Feed forward neural network. The first one. Second one is back propagation algorithm. Back propagation means what is? Okay, I would like to order biryani from Zomato. Okay, right? So how can we order? The first one, you have to activate your location. Yes or no? Then you will give the destination. Okay, so source address, receiver address. Okay, that means what is? When you are ordering something, that will identify latitude, longitude of destination. Latitude and longitude means what is? The first one is x coordinate and the second one is y coordinate. So latitude, this is the longitude. Okay, the first one is x coordinate and the second one is the y coordinate. So this dimension is called as what is? Two-dimensional. What is? Two-dimensional. So that's why you have to activate your location. Okay. Another point. When you are using Zomato or something, you have to location. Activate your location. That will pick your location. Automatically that will find out the destination. Then you will get the order. Okay. The first one, latitude, that means x coordinate. And the second one is y coordinate. Okay. Right? So this is the two dimension. Suppose x is there, y is there. Next one, z is there. Z means what is? Three-dimensional. Can we use such type of things? And maths. Let me launch a rocket from ISRO, from SHAR. In that case, what we use here? Three-dimensional. Latitude, longitude is not enough. Latitude, longitude, and altitude. What's the third one? Altitude. Latitude, longitude, altitude. X coordinate, y coordinate, and z coordinate. Then you are so accurate. Okay, your position is so accurate. We can easily find out. Okay, we can easily grasp. We can easily launch our rocket on the Mars. Based upon which one? This technology. Okay, so that's why in our neural network we can use different models. What's the first model here? What's the first neural network here? Feed forward neural network. The second one is back propagation algorithm. Okay, feed forward means I don't know anything, blind and following sugar, then milk, coffee powder, and what? I don't know anything. Right? So when I get some answer, when I get some accuracy, that accuracy is not good as per my threshold, then I will go back and I will change it. That going procedure, that backing process is called as what is? Propagation. Okay, right? The first instruction, Siri. Do you know Siri? Yeah. Do you know Google Assistant? Okay, what's the first robot name? What's the first robot name? Siri. Hello Siri. My first question. Hello Siri. How are you? My first question. Okay, let's consider it's a robot. I would like to ask a question. Hello Siri, how are you? The Siri will think. The robot will think. Okay, it's an asking, how are you? Automatically that will prepare some answer. From where? From the brain. From the brain. Okay, the first word that will take hello, H-E-L-L-O, hello. Then H-O-W, how. Then R, you. That will prepare some sentence. The mission will think. Which will think? The mission, the Siri, the robot will think. Based upon your question, that will respond. Okay, from where? From the brain. What's the brain? Neural network. So the point here, from the neural network. Okay, see here when let's consider here an object is there. Here one object is there. Here Siri is there. Okay, right? The first question. Here, how can we grasp? How can we find out the object here? Here, some desktop is there. How can we find out the desktop is there? I know some object is there. So it has structure. Okay, but the same Siri, the same robot will think. What is shape? That will think. Okay, right? So that's why neural networks we can use two technologies. The first one is training data set, and the second one is test data set. Okay, the first one? Training. The first one is the training. The second one is testing. Okay, training means what is suppose if you have a laptop, right? So it has 4 drives. 1 TB is there. Okay, we can divide it into 4 partitions. The first one is C drive, D drive, E drive, and F drive. We can divide. Yes or no? Okay, partitioning. We are doing something, right? Something. C includes what is? You can use all system softwares. MS Office, Turbo C, okay, Python, and so on and so on. Yes or no? You can download and you can put it in C drive. Over. Then D drive is there. We can use all personal files. Let's assume all personal files. Okay, E is there. C, D, E drive. E drive is there. That E drive is only for entertainment. Okay, as per you understand E, entertainment. Okay, you can download some movies, some songs, some pictures, or something. F drive is there. Okay, F means that is only personal, office work. Okay, who will divide like that? You only. But TV is there. Not dividing. Okay, the first one. The first 250 for C. Next 250 for D. Next one for E. Next one for F. Okay, got it? Yes or no? C, D, E, F. That is training. Who will train? Myself. Myself only. Who will train this robot? Me. Who will train the Siri? You. Human only. Okay. Alright. Suppose I would like to download a song. Where we put is a C drive, D drive, E drive or F drive? Song. Entertainment. E. That what is called testing. Okay. The song is called testing. Test data set. What's the first one? Trained data set. C, D, E, F, trained. Song is a tester. So that's why your neural network, we can go with what's the first one? Training. The second one is testing. Got it? Okay. So this is the introduction about neural networks. Is it clear? Yes? Neural network means what is? Combination of different neurons, cell bodies, axons, dendrites, and so on. How many networks are there? 2. What's the first one? Feed forward. And the second one? Backward. Okay, right? So it has 2 classifications. What's the first one? Training. And the second one is? Wonderful. Is it clear? Now we will discuss about deep learning. Okay, what's a deep learning? See, deep learning is a subset of which one? machine learning. Here training and testing is there. Training and testing is a machine learning. This is applicable for limited data. Which one? Machine learning. Machine learning is applicable for limited data only. When you are switching from limited data to the huge data, what do you want here? This deep learning. I would like to forecast weather. I would like to forecast tsunamis. I would like to forecast earthquakes, landslides, floods, and so on. Is it huge data or the limited data? Huge data. What we do here? Rate analysis or the huge analysis. In that case, what we use here? This deep learning. Deep learning means depth of the neural network. Now surface of the neural network. Surface of the neural network means what is? The machine. The machine learning only. Okay. Depth of the neural network means the deep learning. Deeply that will analyze. Deeply that will think. Deeply that will put the answer. Okay. See, suppose here one human is there. The machine learning will identify, yeah, is that human. Who will tell? Machine learning. Okay, but the deep learning that will tell the human with name also. The name also. How can you tell the name? It is the training. Yes or no? Some training is there. What the training is? C, D, E, F, something is there. Training is there. Testing is there. Okay, so in this deep learning, we can use huge amount of neurons. Huge amount of the neurons. Okay, in the deep learning. Okay, also this example for deep learning here. Suppose, see. Okay, I can find out. This area belongs to flood prone area. Flood prone area. Okay. We know this floods are. They got the thing. This floods. This river floods. You see what the floods are there? Previously. I saw one. Okay. See. How can we identify the floods? How can we identify? It has a threshold. Okay. It has a threshold, right? So if the surface water level is increasing more than this threshold, then we can treat it as flood. Automatically we can open the doors, floodgates. We can open it and we can release it. Yes or no? Otherwise, flood happens. So in this case, we will use some images. Which type of images? Flood images. For who? For this robot. What is this robot? Artificial intelligence. What is this one? It's a machine. Okay. So which type of technology is there? Deep learning is there. Right? So in the deep learning, which one is there? Algorithms are there. What's the algorithms? Different YOLO, CNN, different algorithms are there. Okay. The algorithm will think based upon your input, just like your song. In the test data set, which one is there? Song is there. The song belongs to which drive? E drive. Very good. Okay. Same thing. The flood images are there. Okay. When we are giving such type of input to this algorithm, okay, automatically that will detect, yeah, this is a flood. Right? That image belongs to D drive or E drive or F drive. Suppose if it is belongs to the C drive, no flood. If it is belongs to the D drive, maybe 30% severity is there. If it is belongs to the something E drive, maybe 90% severity is there. Maybe it is belongs to the F drive, almost over. Almost over. That indicates what is finding testing of deep. Got it? Yes? So this is an introduction about deep learning. See, look at it. Is it clear? Is it visible? Okay. Okay, see. Well, the first one. X1, X2, Xn. What are those? Molecules. 1, 2, 3, 4. Sugar? Yeah. Okay, don't forget. So this is a basic example. If you understood such type of example, automatically this is very easy. Just like a peanut. Nothing is there. In AI, deep learning and neural network, nothing is there. So very simple. Okay, right? What are those? All the inputs. For the next one here, summing unit. Okay, I would like to add only 3. What are those? Sugar, then coffee powder, then milk. What I ignored? Water. Okay, what I combine here? 3. That is the summing unit. You can combine. Then what's the output here? 100% tasty cup of coffee. Some 100% is there. That's the accuracy is there. Okay, right? So here this is the accuracy. This is the activation function. Activation is what is preparing sugar, then milk, then coffee powder. Then what we do? We have to switch on this now. Activating. So no, it's a processing. That is processing. Same thing here, processing. Activation. Activation of those three inputs. Then this is the final output. Output is there. Okay, right? So next one here, suppose here y is equal to g of x plus something. G of x means this one, activation function. Then what are the inputs here? These are all different inputs. This is it feed forward neural network or back propagation? Feed forward or back propagation? First one, feed forward. Is that wrong? Feed forward or back propagation? Feed forward. Why? I don't know anything. Blindly I'm following. Okay, then y is equal to something is that. Y means what is? Output. We are checking the output. Okay, we are checking here. Okay, I would like to do a project. How can we do the project here? The first one, we have to gather all the requirements. Yes or no? Same thing. We are gathering of all requirements. Over. Then what we do? Plan it. Then design it. Then implementation. Okay. Implementation of the development. Move on. So this is the implementation of the development. Then what we do? Test it. Is it correct or not? Test it. Okay. How can we test? So the testing technologies are there. Then in the test, it has the accuracy of 90. Then what we do? Start the launching. Start the product here. If you launch such type of product, we will get 3 by 5 rating. Not 5 by 5 rating. Customer satisfaction won't be there. Okay. If customer is satisfied automatically, it will improve your product levels. Otherwise, what happened? Go back. Go back. Change your inputs. Change your plan. Change your design. Change your implementation. Implementation means what is? Modification of the code. After modification, what we do? Then retest it. Okay. If you get 100%, then what we do? Launch it. Officially launch it. Yes? So this is the same as what is software project management. Right? So what's the first one? The fundamental one. These are all convolution neural networks. Is that algorithm? Then these are all recurrent neural networks, some other algorithm. Right? So this is some other algorithm. All are different algorithms for which one? Neural networks. Okay. Yeah. Next one is the deep learning. What's the deep learning? I already know very well. Which one? This deep learning is subset of which one? Machine learning. This machine learning is subset of which one? Neural network. This neural networks is subset of which one? Artificial neural network. Title is ANN. Artificial neural network. Right? So finally, they are all called as what is? Robots language. The The robotic language is there. Okay, C, right? So, I would like to talk with my friend. Hello, how are you? Okay, right? So, what I'm using here? Analog signal. Analog. My voice is the analog signal. My instruction is the analog signal. Okay, that will reach to which one? Receiver of the mobile. Okay, that will convert from where to where? Analog signal to be signal? Digital signal. Digital signal means what is? It's a combination of zeros and ones. There's a format of the system, there's a format of the mobile, there's a format of controlling systems. Okay, that will convert. Very good. Then, where I am? Sender side. Okay, here receiver is there. The receiver will receive. How can we receive? Is it digital signal or the analog signal? The first one. Analog signal, the digital signal. The first one, phone will receive. Okay. See the receiver. The phone will receive. That means digital signal, analog signal. Digital. Then she will come. She will listen. Okay. Hello, mobile. Yes, I'm fine. That means analog signal. So we are converting from where to where? Analog, digital, then digital to digital. That means phone to phone communication. Then digital to analog. Okay, right? So it is the chronology for mobile communication. In deep learning also what we use? Mobile network. Mobile communication is there. Okay, right? So this is the introduction about the deep learning. Then the next one. See. Take it. Real time example here. See. Okay. I would like to go to this one. Okay. First they will check out. This process belongs to our industry or not. Yes. What do you want here? Based upon your face features, based upon your equipment, they will allow. Okay, you have to use apron, glove, mask, so on. Otherwise, they won't accept. The reason is for security. For security, they won't accept. Okay, for mitigation, for rescue, they won't accept. So that's why what I need here. You have to use apron, then mask, then glove, so on. Okay, here gate is there, industry gate is there, here person is there. Okay, here CC cams are there, different CC cameras. Okay, the CC camera will pursue. There I am, neural networks. In that which one is there? Perceptron. What I perceive here, the CC camera will pass you. This person belongs to a community or not, or industry or not. Okay, how it will identify? Based upon your face features. Okay, this is the first one, case number one, right? So the face belongs to the old one. Old one means a C drive, a D drive, or an E drive, or an F drive. That means managers, then leaders, then tech supporters, then DBAs. Okay, the person will come. That will shut down. Okay, he belongs to this category, DBA category, database administrator category. Then, what is checked out? He is authorized person. Very good. That person is authorized person. Wonderful. Then what we checked out? What are the conditions to allow to the industry? Maybe HPCL, okay, maybe IOCL, okay, as for the measurement, security measurement, they have to wear apron. Then, second one, mask, then glove, then helmet also. Industry helmets are there. Okay, right? So, if you wear all these four, that will allow. The gate will allow. Suppose, if you wear mask only. Okay, you won't wear apron, glove, helmet. 70% accuracy. Yes or no? 30% you are eligible. Remains 70%. You are not eligible. Then we have to wear helmet. Mask is there, helmet is there. Oh, 50%. You are acceptable. Then apron is there. You will wear the apron. 70%. Wonderful. Then you will wear gloves. Then mask, helmet, apron. You are 100% eligible to allow. This is the case number 2. What's the case number 1? The system is checked out. The person belongs to our industry or not, our community or not. So case number 1. Case number 2, that we checked out very well. What you wear? If you wear something, what's the rate of accuracy? Okay, it has more than 80, that will allow. That will allow, as well as that will give alert. What is? That will give alert. Hello man. Otherwise, so mention the name hello. Is also you have to wear next. You have to wear. Otherwise, I don't want to allow. Yes or no? So in that, which one is there? Deep neural. Where is the depth of the neural network? What it identifies first? First your face, left cheek, right cheek, forehead and chin. So this is the box plot. That will identify it's a matching of nose, matching of lips, matching of cheeks, forehead and chin. Wonderful. You are belongs to a community. Then the second one, security measures, rescue operations. That will check out one after one. What's the first one? Glove, then mask, then helmet, then apron. You are 100% eligible. So that means the depth. Depth of the network is there. Depth means what's the first one? Mask. Next step, glove. Next step, apron. Next step, helmet. The deep learning. Okay. Where is the machine learning here? That will identify case 1. That process belongs to a community or not. The machine will check out. Oh, these features are same. Your database, your features are there. You are eligible. That shows the machine learning. But as for the deep learning, that will identify in-depth of the person. Got it? Okay, see, next one. LZ polymers gas leak was there. Visakhapatnam, LZ polymers gas leakage was there. What's the problem? What was the problem in LG polymers? 13 members were dead. 13, 1, 3. So after Bhopal tragedy in Visakhapatnam, so this is the most tragedy, gas tragedy, most disaster. So is it anthropogenic or natural? Anthropogenic means it's a man-made. Natural means we know. Okay, is it man-made or natural? Man-made. Is it natural? Okay. What's the problem? What's the problem in LG polymers? See here, I'm telling all the applications of deep learning. When using such set of algorithms in real time, in the real world, we are using such set of applications. Okay, see, before the LG polymers, see here, let's consider some CC cameras. Yeah, CC camera is there. Okay, let's consider this is the class. I would like to give the attendance. Okay, so not manually. Automatic attendance system is there. How can we give the attendance? How can I give? I don't want to call your roll number 1, 2, 3 and so on and so on. Okay, the system will detect. The system will grasp all the features. Okay, box. Then automatically that will give attendance. That is the point here. Right? Same thing here. In the LZ polymers, what happened? What's the problem of LZ polymers? How many members are belonging to Visakhapatnam? Raise your hand. predicate here. Are those predicates? Yeah. Predicate means what is? You have to write lightly. Yeah. How many members are belongs to Visakhapatnam? I. See, you should know what's the problem in energy politics. What's the problem? Lack of maintenance. What is? Lack of maintenance. There is no perfect maintenance after COVID. Okay, before COVID, wonderful. After COVID, there is no maintenance. So what happened? Sensors are there. Okay, manpower is there. There is no continuous monitoring. Finally, what happened? Gas was made. What's the name of the gas? Sterile. Okay, it is just like sweet smell. The combination of egg and sweet. Okay, the smell is very sweet. Grams up to 1 hour automatically also will die. The sweet smell is a sterile. Okay, right? So in this case, how can we give a learn? How can we detect such type of gases? How can we prevent? Okay, how can we mitigate here? By using the same neural network, the deep learning. This step. How can we do an action? Yeah, alarm. What's your name? Okay, alarm. Okay, that is not basic. The final one. Very good. Alarm. Second one. What do you want? What are the requirements? Right here. First, what we do? Security. What else? What else? Voice is a small. Whatever you do, ask me this. Whatever you do, yeah. This is what else? Sorry, between belongs which branch? See, what? Okay. What do you want? What are the requirements here? The first one, you have to define different sensors. Yes or no? Different sensors. Okay, then what we do? You have to check out all the sensors perfectly. Is it working or not? You have to test it. Okay, then continuous observation. Continuous observation. You have to write some algorithm. Yes, deep learning algorithm or the neural network algorithm. The sensor will grab something from the LZ polymers that will give input to which one? This algorithm. That algorithm will think, that algorithm will analyze, and that algorithm will give the output. Okay, right? So if the gas was leaked, automatically that will give beeping, alarm. Okay, alarm to which one? Neighbors, industry people. Then the second one, APSDR, Andhra Pradesh State Disaster Rescue Force, the first one. Second one, NDR, National Disaster Rescue Force. These are two things. One is belongs to AP, one is belongs to national. Okay, right? So if the tragedy is the highest or the more, then automatically we will call NDR. After Bhopal tragedy, so Visakhapatnam LG polymers were released quantum. So very large. 13 members were there. More than 1,000 members were injured. More than 1,000 members. Okay, what's the problem? Lack of maintenance. So in this case, what we follow? The first one, you have to deploy the sensors. Each sensor means what is? That is receive something. That is receiving from an environment. Then that will give to which one here? Central system. What the central system? A server, a cloud server. The cloud server will analyze. Okay, the cloud server will analyze. Okay, what is going on? Then automatically that will send to which one? Neighbors. Okay, neighbors. Then industry forces, LG Quality forces. Then state disaster rescue force, and followed by a navy. They will enter. They will take the rescue. They will mitigate. Finally, we will stop the disaster. We will stop the disaster. In this case, what do you want here? Simple algorithm. That's it. This is a simple algorithm. Yes. So already work on that one. So I got the patent also. Indian patent office. Okay, right? So that indicates what happened here. You can do something. You can create something. According for the LZ modules. In Visakhapatnam, so this is the industrial hub. As per the Andhra economy, this is the industrial hub. Mainly, okay, right? So here, Rajavan side, right? So many industries are there. Suppose you like to implement such a system, just if you give such a system to the industry, they will use some money. It's a simple algorithm. Very simple algorithm. Deep learning algorithm. You can deploy different sensors. A small server is there that will give all that will give beeping. Okay. 21st society. You can decrease environmental pollutions. Okay. How can we implement all these things? Through deep learning. Okay, see now. So this is a very important application for deep learning and neural network. You see here. COVID-19. All I know, COVID-19. All vaccine. Yes, of course. We are in India. We are following. Hammering. Muscle. Okay. Ashwaming. Right. So different leaves are there. We are collecting a set of leaves. Then we can start and we can cure from COVID-19. Yes, leaves. Leaves has some proteins. There is one. Leaves has some proteins. You are combining such type of leaves. It's source for leaves and three leaves are there. Right? So in this case, what we do here, we have to find out leaf disease. These leaves are very important to COVID-19, all such type of disease. Fine, such type of leaves, such type of mixing. Then, so you can increase your health rates. Right? So that's why here, was a majority here, you have to come in field. And then we have medicine for COVID-19. So it was implemented with my cell phone. Okay, so this is applicable for COVID-19 for cancer patients also. Right? Already patent was there. Indian patent was there. See. Look at there, what do you want here? In same milk, sugar, health. Same thing. Here, I'm using 3 leaves. Okay, then what do you want here? You have to identify the healthy rate of leaf. If it is not healthy, what happened? That is not good. Okay, then what we do? You have to improve. That medicine is not good. If you are using such type of leaf, the dry leaf, okay, wet leaf, or something. So you have to take an optimizer leaf. Then you have to mix it, you have to apply, then you will cure. That's the thing. Okay, this is taken from system of generations of patriarchs. So that's why the picture tells what is patriarchs also. Okay, see. Yeah. Here, this is the rate of. So in Andhra Pradesh, we are using lines. Right? So next one, check this here. Next one, so on, all the steps. Okay, they are using such a copies. Right? So this is the flow chart for how can we implement. Right? So what the first one? This is detection. Which disease? Which disease? Leaf disease. Not COVID. Leaf disease. We are preparing some medicine. Okay? We are preparing some medicine for COVID people. Okay? So, the first one is leaf disease detection. Right? So, that is leaf disease detection. Next one, what is this one here? See, connectivity. What's the connectivity? Here, some algorithms are working. Some algorithm, deep learning, information learning, okay, transfer learning, different algorithms are working, right? So then we are using deep learning algorithm. Here we can take either deep learning, machine learning, transfer learning, or everything, right? So we can understand here convolution neural network. The convolution neural network, this is the algorithm for what is deep learning. Okay, convolution neural network. So that's the giving depth of the neural network. Otherwise, we can use recurrent neural network, RNN, CNNs, RNNs, and so on. Okay, right? So here what I use here, convolution neural networks. Then this is the desktop, this is the mobile. Okay, we are sending information to which one? Desktop as well as mobiles. Okay, the first one, what are those here? Activators. Activators means so we can easily activate. So this is the flow chart. Okay, the first one, taking all the inputs of the leaves. Okay, and the leaf and the disease. Then follow the technology. So the technology, artificial intelligence, right? So in that, visual learning, deep learning, okay, different learning techniques are there. Okay, what I use here? Deep learning. So in the deep learning, what I use here? Convolution neural network. In the convolution neural network, automatically that will send some information to each one. Yes, this is not as well as mobiles. Okay, so this is the scenario for how can we identify. See here. So whatever that is, whatever the technology is, okay, when we are grasping something, we have to store in database. Sir, no, we have to store in database. So where is the database? Here. Our neural network is the database. What's the data? Data means what is it? Data means information. Data means the raw fact. It's the raw material. It's the data. Information is details about the data. Okay, see here. Suppose here, this is the mobile. This is the mobile. Okay, so before the mobile, how can we call that one? It's a raw material. Okay, it's a raw material. Some plastic is there, some iron is there, some steel is there, some copper wires are there, some chips are there. Okay, some encoders are there, right? How can we call all these things? Data. It's the raw material. It's the raw fact. So when you're manufacturing like mobile phone, so it has some information, it has some name. What's the name? It's the phone, the mobile. Some mobility is there. So that means it's the information. Finally, what's the information? Details about the data. Details about the plastic. Details about the material. That is called information. Okay, right? So here we can acquire all the information from the leaves. Then we have to arrange. Arrange the data. How can we arrange? Rows and columns. Arrange. Okay, row means couple, column means attributes. We can arrange like that. Okay, then it needs management. This database needs management. So that's why what I introduce here. What we introduce? Database management system. Okay, then this column to this column, some correlation is there. column to this column, some correlation is there. So that's why what we introduce RDBMS. Starting from data, then database, then database management systems, then relational database management system. Now we are switching from this database to which one? Huge amount of the data. Then what we call data mining. What is data mining? Data mining means what is? Acquiring of some information from where? Databases. Grasping of some information from where? Data warehouse. Okay. After the data mining, then what we do here? Scientifically, we can use such type of data. So that is data science. After the data science, we can analyze the data. TV9, some analysis is there, some forecasting is there. Okay. So is it rainy or sunny? Tomorrow is it rainy or sunny? Okay. How can you predict? Some past data is there. So that means it's a scientific data is there. Based upon that one, we can take the decision. Same thing here. Alright? So the next one is big data analytics. Analysis. Okay. After the big data analytics, huge servers are there. So that's why we are maintaining cloud computing. It's the final one. It's the virtual one. Okay. The first one is data. Next one is database. Next one is database management system. Next one is relational database management system. Next one is data mining. Next one is data warehouse. Then data science. Next one big data analytics. Final one is cloud computing. That's why we can easily operate our data where you are. Okay? We don't want to take any server. Simply we can use AR and VR, augmented reality and the virtual reality. Okay? Right? So I would like to give instruction to the pilot. How can we give the instruction to the pilot? We are looking here in your system. Here different airplanes are there. Okay, you are guiding. Oh, take left direction, right direction. Okay, take off. How can you give all the instructions? Through the simulation. What is? Through the simulation. Through the augmented reality, the virtual reality simulation is there. Okay, right? So in the simulation, by background, which one is there? Deep learning. Based upon the simulation, he will give instruction to the pilot. Okay, physically not there. Physically flight is not there. Okay, based upon the radar signal, radar connection, we will pass the signal. We will pass the signal to which one? Pilot. Okay, some sensing agents are there. So that's why here what we introduce here? Automation followed by what is? Precision automation followed by what is? Alerts. That alerting. We are alerting the pilot. We are alerting the LG polymers workers. We are alerting to the industrial people. Yes, we are alerting to everyone. So that's why in our deep learning, alerting is part and parcel of deep learning. So part and parcel of the deep learning, alerting. Okay. Yeah, good. Alerting. Yes. Yeah. Alerting is what is? The final warning. Final warning to the people. Final warning to the industrial persons. Okay. Reforming. Clear. Skipping. Yes, see here. This is a solution. Everything is there. Everything. Here, that's out there. Technology is there. Database is there. Cloud is there. Alerting system is there. Inputs are there. Everything is there. Okay. You have to. What is the first one? First one. Yeah. Yes. It's not perfect. Anyway. The first one. Data. Data. Field data. Field data means 3 types of leaves are there. Okay, it's a field data. Okay, we are collecting such type of leaves. Okay, then the next section, the first leaf. Is it database and the data report? Everything, the entire thing is data warehouse. What's the first one? It's the data mart. Other database. Okay. So piece, small piece is the database or the data mart. Okay. The everything, the entire thing is data warehouse. Okay. Next followed by data pre-processing. Pre-processing means what happened here? Okay. Some healthy leaf. Okay. What is healthy leaf? Okay. It has good chlorophyll. Okay. Something is there, right? So 70% is good, 30% is not. So 30% is dry leaf, 70% is chlorophyll. Okay. Right? That means what is we can cut it down. We can cut it. Why? There are three processes. What I got here? Only healthy values. And then next followed by convolution neural networks one side. Okay, this is the recurrent neural networks one side. So next one we have is the robot. What I implemented is the robot. The moving robot. Okay. So that will capture such type of leaves. Agricultural sales. Fields are there. How can we find out snakes? Machine learning. This is applicable for farmers. How can we find out? Through observing. Observing only. Snakes. Sound. Yes or no? So, therefore, what we deploy? Sensors. Okay, they are having many applications. Same sensors we can deploy, road agents. Okay, right? So, if you found such type of sneezing, automatically your beeping will increase. Okay, not beeping, your beeping. Okay, your alarm. That alarm will give alert. Okay, alert to which one? Farmers. Okay, right? Suppose. Okay, suddenly, it has to happen. Snake, right? What happened? In Yoga snake, what happened? What we do? What's our mitigation? What's our rescue? For technical people. Yes? What you do? What you suggest? How can we save that person? How can we say? Nobody is there. Single person. Snake pet occur. Then what we do? We have good technology. We learn something. We implemented something. Sensors are there. What we do? That's fine. So in this lab, system is does it give what is analytics? So same thing. Farmer face will be witnessed by CC camera. You have to deploy CC cameras. Okay, case 2 or 3 road areas. You have to deploy. Okay, right? So you will stand like that. Very good. In that case, there is no other. Okay. We can put after 5 seconds or 8 seconds some drowsy and fallen state. Okay, suddenly it will fall. Automatically that technology will give alert to which one? Their family. Yes, their family. It's the case. At the same time, we can use earth sensors. We have to identify the prone area, then we have to deploy earth sensors. The earth sensor will identify these sounds that will give alert to the mobile as well as keyboards. Alerting. Okay. See. So this is the map of India. The map of Andhra Pradesh. Okay, what are this one here? Ashwagandha. Maybe correct? No. Okay, right. So this is something. How many leaves are there? 3 leaves are there. You're correct. What upon ovate. Okay. Leaves. How can we identify? It has good chlorophyll. How can we identify? What else? What else? Some dry leaves are there. It has same texture. Okay. See here. Okay, here vegetation is there. Vegetation. Vegetation means what is? Vegetation means what is? Leaves, trees, greenery. Yes? Okay. What's the color of vegetation? Wow. Absolutely not. Absolutely not. Sorry, it's not green. You're telling something. No. You are grasping green color only. As for the RCB, as for the EMR, you are grasping green color only. The actual color of the leaf is, the actual color of the vegetation is red. Yeah. The actual color is red. Okay. Right? So that's why the satellite images are in which color? Red color. Satellite images. Okay. Just you can go. Okay, you can go to the Bhuvan, the website of the Bhuvan, ISRO website. You can download all the forest websites, forest games or the forest trees or something. You will get in red color only. Okay, see, you have to identify what is texture, then dry leaf, wet leaf, or some. Okay, so this is belongs to one category. This is belongs to some other category, right? So, okay, we got all these things. These are the different types of diseases. This is the one type of disease. This is the one type of disease. Okay, right? So this is a terminal. Name of the terminal. Yeah. Okay, this is terminal. Just like a COVID-19. Okay, these are some terminal. So this is such type of disease. This is such type of disease. Okay, so this is a Itania, Somalifan, Alzheimer's. So these are different diseases. Okay, then what happened? What is this one here? This is also same diseases, right? So this is the medical plant data set. Whatever it is, or brain is there, or neural network is there. Yes, sir? Yes. Or neural network is there. That means that it was something. Same thing is the brain. Okay, this leaf has this size. Okay, it has some capacity. So this is the data set. The same mission level language. So this is the chronology. The flow chart here. So the first one, start. Then, what do you prepare? Dataset means you have to collect all the leaves. Okay, then next one. What's the algorithm? You know. What's the algorithm? You know. Why go? Here go. You know. Okay. What's the you know? You only look once. Okay. It has different versions. You look 8, 9, 10, 11. Why do you small these things? Suddenly you have to remember 80% accuracy, 90% accuracy, 99, 100. Yes or no? 100% cup of coffee. 80, 90, 99, 100. So that's why we are using 08, 09, 010, 011. Why? The highest version is super accuracy. Okay, right? So next followed by what is? The last one? Yeah. The next one? Then, yeah. You have to take an action. Okay, if it's true, then we can go. If it is false, you have to go like this. Okay, finally what we do here? Ending. Right? So before the end, what we do is spread. Okay, what's the problem? Okay, what are the different types of diseases? Okay, this is circular. You have a disease. What happened here? What's the difference between this one and this one? This is the blueprint, this is the design. It's the design of the robot. Okay, that robot. Which one is that? Microprocessor. 8 8085, 8086. Okay, in the microprocessor, which one is there? Circuits are there. Okay, what's the circuit here? Conventional circuit or sequential circuit? In the circuit, different gates are there. Another gates, AND gate, OR gate, NAND gate, XOR gate. Okay, different gates are there. So in the gate, which one is there? Yeah, digital system is there. In the digital system, which format is there? Binary format. What's the binary format? System format. So finally, we are preparing the code for system. So this is our understanding. What is this one? This is the system understanding. Okay. So this is the part of the software. This is the part of hardware. Got it? So in this hardware, what we follow here, we can use different processors. Nowadays we are using AMD processor, Intel processor, okay, Raspberry Pi, okay, Arduinos, okay, iOS. Yes or no? What are those? These are the different processors. Same thing, here also we can deploy different processors to process something. So this is the original design. How can we do it correct? Okay. Finally, what we do? We have to implement the product. We have to launch. We have to design like that. That's the point. So suppose I would like to apply for a patent. We have to show like that. This is an entire project. Okay. If the capture is one person, okay, it will grant and it will implement. It will not be. So that's why I don't want to variance. Okay, that's why mark today was it's a symbol. It's a copyright. Okay, right? So this is the design. The next one here. So what are those? What are those? Accuracy levels. What are the algorithms? 0, 8, 9, 10, 11, and so on. Okay, right? All these algorithms has low accuracy. Low accuracy. What I implemented, that algorithm has 99.98% accuracy. If you are using same algorithms, your research is bluff. You have to take such type of things. Based upon that one, you have to design and you have to re-implement your original algorithm. You have to launch such type of product. Otherwise, copyright. Otherwise, nothing is there. Okay? See. Yeah. What happened here? Leave this is, then this is the software connection to which one? Matrix. It's a confusion matrix. Okay, which one is good, which one is bad, which one has the chlorophyll, okay, which one is the dry leaf, okay, session. So this is the results. Now see. These are the results, but you don't want to go with all these things. See here. Okay. This is the actual correct. Okay. So the main thing of this correct is the moving over. Okay, it's a moving over. Right? So here, what I use here, rainfall and the precipitation sensor, thermal sensor, temperature sensor, okay, chlorophyll identifier sensor, 4 sensors with alarm. Okay, then, so this is just like one robot. Finally, what happened? That will identify just as a system. Okay, here that was used in the field. Not only this is applicable for alien disease detection, this is also identified snake bites. Okay, snake bites, snake series, snake sounds. C. Right, told ya. Industry is there. You have to identify the face feature. Left cheek, right cheek, forehead, chin, then face features some laboratory here. Right? C. What's the rate? What's the rate of the safety? The first one, safe or unsafe? What's the reason? Is there any mask? Is there any helmet? Okay. Is there any glove? Is there any apron? Finally, unsafe. What's the rate of the unsafe? 80%. Got it? Next one, somewhat good. Next one, somewhat good. Okay, so this is the thing. Is it okay? What is that? Anyone? What is that? Yes, can you explain? So, this is the information relevant to neural networks, deep learning, and this type of things. Okay. We discussed how many applications? Almost 5 applications. The first one? Not counting. First one. Snake bite detection. Yes. Okay. Next one. Leaf disease detection. Okay. Next one. Industrial safety. Okay. Next one. Gas leakage detection. Okay. Next one. Automatic attendance system. How can you use all these things? Our neural networks are. Okay. Any doubts? Any questions?
He knows all the culture of India, but he took it because he's a guest now. Right? Thank you and you accepted it. You all can go for lunch. Come back again at